For number 34, we're asked to solve for z if the area of the given parallelogram is x over y cubed. Okay, first thing we need to remember is that the area of a parallelogram is base times height. And here we are given an expression for area, for the base, and for the height. So I'm going to substitute those in. So we have a lot of variables here with exponents, but we're going to go through using the mathematical properties that we use with any fractions. If we're going to multiply fractions, we multiply the numerators and we multiply the denominators. So we have y over x cubed equals 12 times x squared times y times z squared. I just put them in alphabetical order. When we multiply the denominators, I put my coefficient in the front, or first, and then I have my x, y to the 4th, times z. So remember, we're trying to solve for z, so that's what we want to have isolated on one side of the equal sign. But before I do that, I'm going to simplify this whole side, because there's a lot of stuff that cancels out. Okay, first, 12 over 3 reduces to 4 over 1. Okay, so a 4, and then we don't have to put the 1 down there unless there's nothing else. Okay, the x squared over x cancels out and leaves 1x here and none down there. Okay, for the y's, this one goes away and this turns to 3 on the bottom. And for the z's, I have z squared on the top. The one on the bottom cancels one of those out, and I'm just left with z on the numerator. So that simplifies things quite a bit. I have y to the 3rd power in the denominator on both sides. So I actually can multiply both sides by y to the 3rd power. To simplify even further, I have x equals 4x times z. So again, we're solving for z. We want z isolated. So since it's multiplied by 4x, I'm going to divide by 4x. 4 over 4 is 1, x over x is 1. So I'm left with z, 1z. And then again, x over x is 1. So I have z equals 1/4. For number 35, we're told to find the measure of each angle in the triangle. So using the triangle sum theorem, I know that all 3 angles of a triangle add up to equal 180. So I'm going to write an expression that adds all of those and set that equal to 180. Okay, if I can solve for x, then I can figure out the measure of all of those angles. So I'm going to simplify by combining like terms. And since I see I have a quadratic equation, I'm going to get everything on one side of the equal sign and just have 0 on the other side. So to do that, I'm going to subtract 180 from both sides. So I have x squared plus 5x minus 176, and that is equal to 0. When we have a quadratic equation, you can factor or use the quadratic formula to solve. Whenever we factor, we are looking for the factors of negative 176 that add together to give me positive 5. So looking at those factors, I know that if this is 16 and negative 11. They multiply to give me negative 176, but when I add them, I get positive 5. So I can use those factors. So that's x plus 16 and x minus 11. And that equals 0. If you want to check and make sure that you did that correctly, you could just multiply these two back and make sure that you get this expression again. Okay, so when we have both of those, we have to set each of those equal to 0. So I have x plus 16 equals 0. That is when x equals negative 16. And I have x minus 11 equals 0. So that is when x equals positive 11. So now I have two options, or two possible x values. So now we go back to the actual figure. Does it make sense with this particular problem to have negative values? If I put in x equals negative 16 right here, I would end up with a negative angle measure. And I can't have a negative angle measure. So that allows me to throw this one out and just use x equals 11. So when I use x equals 11, I find that this angle is 121 degrees. This one is 24 degrees. And this last angle would be 35 degrees. Okay, for number 36, we want to know what are the two possible angle measures for the given central angle and inscribed angle. What we need to remember is that a central angle is an angle whose vertex is at the center and it is equal to its arc measure, and an inscribed angle is an angle whose vertex is on the circle. It is equal to half of its arc measure, intercepted arc measure. So just in general, if this arc measure was 80 degrees, that means this angle measure would be 80 degrees, but the inscribed angle measure would be half of it. It would be 40 degrees. So that tells me that two of these equals one of these. So that's an equation that I can set up to find what the value is for x. So 2 times x squared plus 5x minus 1 will equal 3x squared plus 3x plus 10. And now I have an equation that I can solve for x and substitute that back into those expressions and find the angle measures. So remember, when we're multiplying a number to several terms in parentheses, we have to distribute that multiplication. So we end up with 2x squared plus 10x minus 2. And I want to solve for x, and this is a quadratic, so I'm going to have to get everything on one side and 0 on the other. So I'm going to subtract negative 2x, subtract 10x, and add 2. And I'm going to do that to both sides. So I'm left with x squared minus 7x plus 12 equals 0. And again, I can factor it, or I can use quadratic formula. And I'm going to use, for 12, I know that 3 and 4 are factors, and negative 3 and negative 4 are factors. And when I add the negative 3 and the negative 4, I end up with a negative 7, so those factors will work. So I'm going to use those and replace that expression with x minus 3 times x minus 4. And when I set each of those pieces equal to 0, I find that x can equal 3 and x can equal 4. So it gives me two possibilities for my two angles over here. So So I'm just going to go back and substitute it in. When x equals 3, this angle will equal 46 degrees. And when x equals 4, will equal 70 degrees. When x equals 3, the inscribed angle will be 23 degrees. And when x equals 4, it will be 35 degrees. So here are our two possibilities for the inscribed angle and the two possibilities for the central angle. For 37, we're asked to find the length of KL. What we need to remember when we have two secants that intersect a circle, but intersect each other outside of the circle, we have a theorem that says the product of the whole secant times just the part outside will equal the product of the whole secant times just the part outside. That tells me that 6 plus 4 times 6 will equal x plus 2 times x. Okay, if I simplify that, 10 times 6 equals 2x plus 2 times x. Okay, so I end up with 60 equals, and remember when we multiply this x, we have to multiply everything in the parentheses. So I get 2x squared plus 2x. So here we have another quadratic, but one thing we can do is divide everything by 2, or factor out a 2 and divide it out. So if I divide this by 2, this by 2, I end up with 30 equals x squared plus x. That's a little bit easier to work with. And of course, I'm going to subtract the 30 on both sides so that I have everything set equal to 0. So x squared plus x minus 30 equals 0. And I choose to factor this. You could use quadratic formula if you'd like. But the factors of negative 30 that add to give me positive 1 is a positive 6 and a negative 5. I get x plus 6 and x minus 5. So when x plus 6 equals 0, x is negative 6. When x minus 5, and when x minus 5 equals 0, x equals positive 5. And since this x represents a length, so here I have x that represents the length between j and k, I'm never going to have a negative length. So I can actually throw this one out and just use x minus 5. I'm sorry, x equals 5. And since I'm looking for the length KL, x plus 2 represents KL. That would be 5 plus 2, which is 7 units.